Let's move to our next topic, that is try catch block. The question is, what is try catch blocks? Try catch blocks are the exception handlers. Those are mainly used to handle the exceptions from piece of code. Okay. If you have some certain piece of code, some certain number of lines of codes where you are expecting some exception, what you will do, you will just simply put that piece of code inside the try block. Okay. And if during the execution of that piece of code exception will occur, then your program will not abnormally terminate. Instead of that, on the line inside try block where exception is occurring, from that line try block get terminates and catch block will catch that exception and will execute its piece of code, whatever the code you have defined inside the catch block. So it works like that always. Whenever any exception occurs inside try block on any line, then try block will terminates and catch will execute and it will execute its piece of code. So you will always define the alternative code inside the catch block which you only want to execute when your try block will abnormally terminate. So in that way, you will always have alternative path of execution of your program and you can avoid abnormal termination of your program or your project. Now, this is a very high level information about try catch block. Let's try to better understand its internal working and how it works by this example. So first of all, I am showing you if you are not using any try catch handler, then what will happen. In this program, I'm just taking a first integer type of value from end user and then second integer type of value, and I'm just making a division there and I try to create arithmetic exception here. Okay, so when I run this, it will simply uh, ask for first value. For example, I am saying 4, and for the second value, if I am saying 2, it's working absolutely fine, right? Rest of the code is going to execute. It will just print the result and then rest of the code will execute. Now, let's change the scenario. If I once again run this and this time I am passing the value as 5. For the second value, I am passing 0. You can see when I'm passing second value as 0 and it is trying to make division, it is getting exception. On this particular line, when I'm performing division, it is throwing exception and then rest of the code is not even getting execute. It is just terminating abnormally my program from this line. Okay, and that is the problem when we are not handling the exceptions generally occurs. Our program will start getting abnormally terminate. To avoid this, we need to use handlers. Now, let me try to handle this by using handler. So this is my suspected code where I am expecting some exception could be there. And that's why I'm putting this piece of code inside the try block and I'm printing the result. If something goes wrong, then exception will be catch here and then alternative code will execute. As of now, I'm just printing the exception. I'm not doing anything else here and then rest of the code I'm executing. Okay, now what is going to be happen if I run this code once again? What is going to be happen here? I am getting some output as it is asking for first value and then second value. For example, this time I'm saying 0. Then it is trying to execute this piece of line, right? What is internally going to happen now? When I'll say 0 divide by 0, it will check this condition, because when I'm saying number divide by 0, there is an abnormal condition raised. You can't divide anything by 0. For that specific abnormal condition, there is an exception class already defined by Java library, Java vendors, that is arithmetic exception class. So what that compiler is going to do is it is going to map this abnormal condition with that appropriate exception class which is defined specifically for this abnormal condition, and then create the object of that exception class and throw that object of exception here, of that arithmetic exception class object here on this try block. Now if you put this line number 18 inside this try block, then that exception will be goes to the further and will check in the catch block whether you are using same type of reference variable to catch that object or not. But if you are not using any handler, then what is going to be happen, that exception will be further forward to the compiler again and then it will terminate my program abnormally and print that exception on console. Okay, so it will abnormally terminate my code. But when I'm using handler, exception object will be throw here and then it will be try to catch inside my catch block. You can also have multiple catch blocks. So it will try one by one which exception class or reference variable is eligible to catch that exception object. My arithmetic exception of E is eligible to catch that exception object. It will catch that exception object and it will print that exception object, and then the rest of the code will execute. So you can see it is catching the exception, printing the message of exception, and then rest of the code is executing. So my program basically now executing alternative piece of code which is defined inside the catch block in case if try block is throwing exception. This is the major advantage of using try catch block. Try catch are the handlers, are mainly used to handle the piece of code from where exception can be occur. Okay, and for each abnormal condition there is some specific predefined exception class already defined by Java developers. Compiler will automatically map that exception class object with the abnormal condition and create that object of that exception class, throw that object here, and if you will have appropriate catch block which is basically eligible to catch that object, will execute that catch block, and then the alternative code will get executed. So this is how we can avoid abnormal termination of any code. Okay, that's the main advantage of using try catch block. Now, there are few key points that you must have to remember. The first is always define try block inside some method. You cannot define try catch block outside the method like init block or static block. You must have to define them within method. The second important point is, as you guys already have seen, that inside the try block for this example, line number 18, this line is executing, and if exception is occurring on this line, then rest of the lines of try block will not going to execute. So for an instance, just assume that, let's say if there are 5 lines inside try block and exception is occurring on first line, then rest of the 4 lines will not going to execute. So always remember this, that whatever the piece of code you are putting inside the try block is fully dependent on the line from which exception can be occur. In case if exception will occur, then rest of the code is not going to execute. So only put the piece of code inside the try block from where you are expecting exception, so that rest of the code will execute through catch block or after the catch block. Okay, or else there is another scenario where you have, let's say, 10 line of code, and on first 2 lines of code you are expecting some exception, and you want to execute rest of the 8 line of code only when the first 2 lines are executing successfully. If any exception occurs from first 2 lines, then you don't even want to execute rest of the 8 lines. Then you will put all these lines inside the try block. Then it is making sense. So you must have to understand what is your requirement, and based on that you have to make the decision that which piece of code or what are the number of lines or what are the lines that you want to define inside the try block. The next important point is always define try block followed by the catch block or finally block. You can choose any one of them. It's not mandatory to define every time catch block. Even you can define try block with the finally block as well. Let's move to the next example. In this example, I am showing you that you can even define multiple catch blocks with same try block. Okay. In that case, you can see here, first catch block is only catching arithmetic type of exceptions. The second catch block is catching only array index out of bound type of exceptions. And from my try block, there is a possibility that on this line, I will have arithmetic exception, and on this line I might have array index out of bound exception. So my try block could throw both type of exceptions. Now let me run this program. When I'm running this program, and let's suppose I am saying enter first value as 3 and the second value as 0, then what is going to be happen when this first line is going to execute x divided by y, exception will occur. Which type of exception? Arithmetic exception. And it goes that exception object here on the first catch block, and the first catch block reference variable is of arithmetic exception type, which is eligible to catch the arithmetic exception object, and then this catch block will execute, and from there itself, from the first catch block itself, it will terminate and will execute rest of the code. So it will not going to execute all the catch blocks. It is going to work like a if else if statements. Only one catch block will execute at a time. Let me run this and you can see this first catch block is going to execute, and then rest of the catch blocks will skip and rest of the code will execute. Similar to that, if I run this code once again, and then let's suppose if I'm saying enter, it's fine. Now I'm trying to generate a second type of exception, which is array index out of bound exception, and for that reason I'm just making this I as, let's say, 8. My array size is of 5, and when my array will try to access the index 8, it could not be able to access because that index is not even reserved. Then array index out of bound exception object will be throw here on this line, and then will try to catch here, but it will not catch that because it is of arithmetic exception type. Then next catch will try again for catching the array index out of bound exception object. It will catch that and it will print the message, and then it will execute rest of the code without any problem. So you can see I am saying, let's say 4 and then 2, doesn't matter, it is throwing arithmetic exception, and then rest of the code is executing because this second catch block is executing. So you can define any number of catch blocks after try block. One more thing you have to take care, that is, for example, for this example, let's suppose I am defining first catch block which is of exception type. That means any exception, doesn't matter what type of exception your try block is throwing, every time that exception will catch on this line only, because exception is the parent of all exception classes, right? So that means it is eligible to hold any child object. That means this catch will going to execute every single time. That means if you are defining multiple catch blocks, rest of the catch blocks will never get execute. Those are unreachable codes, and for that reason you will start getting unreachable code exception. Okay, you can see here it is saying unreachable catch blocks. So always remember, whenever you are defining multiple catch blocks, the hierarchy of defining the catch blocks should be child to parent direction. Okay, you should define arithmetic exception first, then array index out of bound exception, then only the parent one exception type, so that if you will receive some specific arithmetic exception, you will execute the alternative code in case of arithmetic exception, and in case of array index out of bound you will raise some other alternative piece of code, and when some other exception will occur from the code, then you will execute some common alternative code which you want to execute every time when any exception, other type of exception will occur. So always remember this, you must have to define the catch blocks in the child to parent exception reference orders. There's one more important concept in try catch block, that is nested try catch block. What is nested try catch block? When you define try catch block inside another try catch block, that is known as nested try catch block. When we need to use this, for example, in this piece of code, you can see I have multiple lines inside try block, and in those lines there is some specific lines which can throw a different type of exception. Okay, then you can define that piece of code inside another try catch block inside my try block. Okay, so for example, from this line I am expecting null pointer exception, so I am defining this piece of code even inside my try block. So if any exception will occur, that will catch or handle here itself, and then rest of the try block will execute. So when you don't want to abnormally terminate your try block, main try block entirely, instead of that you just want to handle those 1 2 lines inside the try block itself, you will define nested try catch block. Okay, but if you don't have that type of requirement, if you have 10 line of code, and let's suppose for first 2 lines you are getting exception and you don't want to execute rest of the lines, in that case you will use simple normal try catch block. But if inside your 5 line of code, on 1 or 2 lines you are going to expect some different type of exception and you want to handle it inside my try block only, then you will use nested try catch block. So it depends on your requirement. What is your requirement? You can go with different approaches for different requirements. Now we are pretty much done with try catch blocks handlers. We have learned what is try block, how it works, what is catch block or multiple catch blocks, how those works together, and what is nested try catch block and what is the need of try catch blocks.